join our form, okay, or join dependency. Fine, join dependency. Okay, so what is first thing is what is join dependency, right? We will see. Yep. That's yours. Multi-valued join. Yeah. So the definition of join dependency is this, which says that if you divide a relation, if you divide a table into multiple relation, okay, then when you combine them, you should get the original relation back. Fine. That means if you have a relation R, okay, and the R relation is broken down into R1, R2 up to Rn, n number of relations you are getting out of R. Fine. Then when you combine them back, that means when you join them, all of them are joined into a single relation, then that relation should be same as the original one. It should not have any other additional data in it. Okay, if you are finding any additional data or if any additional row in it, then that will be called as wrong tuple or wrong row, or that is called spurious tuple. Fine. So the definition says that a joint dependency denoted by JD bracket R1 to Rn specified on a relation schema R. See, this relation schema R is the original relation. Okay, this specifies a constraint on the states R of R. That means whatever data you contain in the relation, on all the states it should be applied. That means for every legal state R of R, it should have a non-additive joint decomposition. Hence, for every such R, we have this is pi is your projection. This thing we will get clear on the relational algebra part. Projection means selection of all the columns in R. That means selection of all the columns in R1. Suppose R is a table, okay? Say this example. This is a relation R. So I am breaking that into two different relations. One is this 2 into R1, this 2 into R2. Okay, so I am making two relations out of this particular relation. So when I combine R1 and R2, I should get exactly this number of rows. I should not get any additional rows. Fine. So if you combine them means that is called natural join. You might have remember from the last class we saw equi-join and Cartesian join. Remember, join means you are combining two relations based on a common attribute. Okay. In that case, we had DNO, D number, PNO, project number. Those were the combining attributes. Some examples we saw. Fine. So in those cases, when you combine two relations in natural join is a type of join where the combining attribute, the common attribute names are same. In the previous example, you saw that the names are different. So that was called equi-join. You are writing d department dot dno equals to employee dot d number. Okay, so that was the what that was the equi-join. But when you write natural join, that is uh, what that is called, means for that there is no requirement of any equals to sign. So that is a case of join. So when you join R1, R2 up to Rn in terms of natural join, you should get the original relation back. For example, see here.
Sir, screen is not visible. I cannot see your screen, sir.
Anyone else? All of you can see or only one?
It is visual.
Anyone else who cannot see?
The screen is visible, sir.
Then what's the name? What's saying? Bulbul Kumari, no? Bulbul,
Yes, sir.
you just log out and log in again. You should be able to see.
Okay.
Seeing it now. Is visible now, Bulbul, or still not visible? Visible now or not?
Sir, not.
Now?
नो सर मेरा एक प्रॉब्लम है नेट का कनेक्शन बहुत कम है मेरा 7.3 केबी पर सेकंड है शायद से
Hmm.
पता नहीं क्यों नहीं यार
Okay, no issue.
इसी
Because anyway, I am going to upload this recording in the YouTube, so you can see it at your own pace. Whatever speed you are having, you can see it then. That is what my aim is, that the YouTube should have all the videos, so that no need to download. You can just see it.
ओके थैंक यू सर
Just be in line so that you can listen what I am saying. Then you can see the recorded video later also. Okay. So I was saying that when you divide a table, suppose this is a table EMP that I am dividing into two different relations, R1 and R2. R1 contains two columns, ename, pname. R2 contains two columns, ename, dname. Okay. Say I am doing a natural join on this two table. Natural join will be done based on two same columns. Here ename is same among these two. Ename is same. So based on ename, it will be combined. How it will be combined? The first row, let me write it. The combination of employee project and employee dependent will be having this data. We have ename, pname, ename. These three will be there because here ename is common, no? So during combination it will be there, but after you perform the query, ename column will be automatically removed. So that at the end, if you combine these two tables, you will get only three columns: ename, pname, and dname. Okay, so the data will be like this: Smith X. Now I am trying to explain what do you mean by spurious tuple. Okay, after that we will go to the join dependency and 5NF, those things. So don't worry about those things. Now you be clear on what is spurious tuple. In the process of spurious tuple, I am saying that when you divide a table into two or three or four or five n number of tables, when you combine the tables combine the divided tables back, it should give you the original table. That I am trying to prove here. Okay, original table means whatever data was there originally, it should be there. There should not be any additional tables coming in, or additional rows or tuples coming in. Okay, so this was my original table. This was my original table. Now I am trying to join them. Smith X with Smith John. Smith is common here. In the first two rows, Smith is common. So I am joining Smith X with Smith John. It is joined. Then Smith X with Smith Anna. Okay. Now Smith Y with Smith John. And Smith Y with Smith Anna. Okay. Now this is the combination. Now since this is a natural join means where it it is a type of join where you combine two tables based on a similar column. So here e name was similar column. So based on that it got combined. Now one of them will be removed because e name is already present. Okay. Now you see here, this is your original table or not? Your original table contain this much data or not? Smith X John is here. Smith X Anna is also here. Smith Y John is here. Smith Y Anna is here. So this is your original table. You got it back. So this kind of uh, combination of this kind of join did not introduce any additional row. Okay, so this is fine. But if you consider this table, okay, supply table, where there are same three columns, S name, part name and project name. Okay, suppose I divide into two different table I made out of this. One is S name with part name, another one is S name with project name. Okay, then you see whether any additional row will come or not. S name, you getting what I am trying to say? Any doubt what I am trying to say? I am trying to convey here that there was a table project which there was this table supply which I divided into two different tables, R1 and R2. Okay, S name, part name in one, S name, project name in another one. So this is the resultant table where the data will be filled like this. S name got combined with Smith, so Smith and Smith is equal. Now bolt will be combined with project. That means Smith bolt will be combined with Smith project. Similarly, wherever Smith is there, it will be combined. Smith is here, so Smith bolt will be combined with Smith project Y. Smith not will be combined with Smith project X. Smith not will be combined with Smith project Y. That means the basic aim of this type of join is that it will try to find common value out of the common column. Here common column is S name. Okay, the common value out of this, each row will be seen. That means each row will be compared together based on the value present in the common column. Here Smith will be checked in all the rows. Where Smith is there, now this Smith is there. So once this matches, then the rows will be combined. Smith bolt will be combined with Smith projectiles. That's why I am writing here. The first combination is Smith bolt with Smith projectiles. This is the first combination. Fine. Then second combination will be Smith bolt with Smith projectile. Now again, Smith will be matched with this row. Smith will be matched with these two rows. So Smith knot will be combined with Smith projectiles. Smith knot will be combined with Smith projectiles. Then again, Smith knot will be combined with Smith projectile. Fine or not? Getting? Likewise, you go on combining the rows. Again, it will be having Adamski bolt. Then it will match with Adamski project Y, Adamski project X. Fine. So if I write Adamski bolt with Adamski, any doubt? No problem, no? It's clear. Adamski. Next combination will be what? Adamski bolt with.
Sir, there is another Smith in the supply table. Last one.
Where? No, I'm not saying that. I'm saying that this was your original table in the supply table. Okay. Then you divided it uh, into these two tables. This is a, oh, this one you are saying below this.
Yes, sir. For writing relations of Smith, we need to consider the third Smith also.
This one, no?
Yes, sir.
No, as for the example, these two rows you have to skip. These are spurious tuples actually. Oh, the original relation contain these many things up to this dotted line. Up to this dotted line. It is given here. If you read the book, no, it is given here. The example considers up to this only. That means is many persons up to this part. These two rows are not there. These are spurious tuples. We'll see in a small point. These are the two tables you got out of this. Here it is mentioned somewhere. Let me show you. Uh, mm, there is a point where this part is not there. You assume that the table is up to this. Okay, up to this 1, 2, 3, 4, 5, fifth row. These two rows are not considered. That's why I am including this. Up to this point, you say. Okay, and you got this relation and this relation. Only 5 rows. 2 Smith, Adamski, Walton, and Adamski. Up to this point, you consider. Fine. Now here only you can see one thing. Considering this Smith, forget about the other combinations that you will get later. This thing though will not be there. S name will not be there in the final result because this is a natural join. Only one row, only one column will be there because this column was same as this column. So this column will remove from the result. Adamski bold project Y, Adamski bold project X. Suppose up to this only. That means I am saying that whenever I combine all the possible combinations out of this R1 and R2, I should get back my original relation up to this point. Yes or no? But you see here, Smith bold project X. This row is coming as in the resultant. Whether this row originally was present in the R or not. Smith bold project X. Smith bold project, it is present. Okay, so this is a valid row. Okay. Now search Smith bold project Y. Whether that was there in the relation. It was not there. Still you are getting. Then another one is Smith not project X. Smith not project X is also not there in the relation. Still you are getting that.
Sir, number 2 is there in second position in at last, na, sir.
No, up to this you have to not. Yeah, you don't have to see these two rows. You have to see only up to this. Up to this part. Even if you see this one, no. Okay, let it be like that. You see this one. Then you find this row, Smith not project X. Smith not project X. Was it there in the original relation? No. It's not there, but still you got. Okay, that means whenever you combine the divided relation back so that you get the original relation R, you are not getting. You are getting some additional tuples. These tuples are called spurious tuples or invalid or wrong data. The project X and are never combined. Not is combined with project Y when it is with Smith, but here not is combined with project X. This type of rows will come whenever you try to join back the divided relation into the original relation. Okay, so these are called spurious tuples. This is called additive join. That means some additional rows are getting in when you are trying to join the divided relation. But your joins should be non-additive joins. That means there should not be any addition of spurious tuples. Fine. So there are these terms you have to remember: non-additive join, additive join. Non-additive means there should not be anything added extra, which are wrong data. Fine. This is your case of spurious tuple. So what is the solution? Know here that whenever you are dividing a relation into this type of relations, you are getting wrong data. But if you divide this relation into these three, R1, R2, R3, then you try to join all R1, R2, R3, you will get correct data. There will not be any additional tuples like this. You can try. Suppose Smith bolt will be combined with Smith project X. Okay, then these two can be combined with suppose for Smith I am considering Smith bolt. That means you have to combine one by one. R1 will be combined with R2. That result will be combined with R3. Shall we try? Here already you have combined Smith bolt, Smith project X, then Smith bolt, Smith project Y, this one, then Smith not, Smith project X, then Smith not, Smith project Y. Okay, this three you have already, this four you have already got. Then you try to combine. Suppose I am removing this because I am considering only the Smith part. I will combine this resultant with R3. What will be the additional tuple? Part name, project name. So I can combine based on either part name or project name, anything. Suppose I am combining based on part name. Bolt. Bolt is there, so it will be matching with this. So Bolt and project X will be there again. That means Smith, Bolt, project X, that is a valid relation always. Then Bolt and project Y. Bolt and project Y is already there. So this two will be still valid because as per you I am considering this one also. But you will never get Smith not project X. You see, not project X is not present here. Not project X is not present. So you will never get this combination. But you will get not project Y because that was present here. Smith not project Y, that will be combined with this not project Y. So we will get this row. So this 1, 2, 3, these are valid. This is invalid. Original relation back. But if you combine either R1 or R2 or R2 or R3 or R1 with R3, you will not get the R. Any doubt in this? Nikhil Singh, any doubt in this? Nikhil Singh,
Yes, sir.
what happens? You always want to you connect late. Whenever you connect, you just sit silent. There is no response. Last time you are absent also. You are
Yes,
connected,
sir.
but you are not there.
Well, in the last class, I went to the loo, and at that time, you took
Last
the
to
test.
last class. Last to last class.
Yes, sir. Last to last class, I went to the loo, and you took the attendance that time. That's why I was not present.
No, I was asking. No, you were this is the
Yes,
class.
sir. Yes, sir. In the last 10 minutes, you were asking. I went to the loo. I just missed that attendance. Wow.
Okay, tell me the your this concept is clear now. What I am trying to say.
So my internet is not good. I can't see your presentation, sir. So I'm here right now in Bihar, and
Okay.
there is no internet connection here proper. I can just listen.
Okay. Any other person has any doubt on spurious tuple, generation of spurious tuple? Why spurious tuple is coming? Because the division is not proper. What is why you are dividing? Because in the process of normalization, you are always in order to achieve higher normal form, you tend to divide the original relation into multiple further relations. But as for the non-additive join property, when you join the tables or the relations back, as for the natural join, it should give you the original relation. But in some cases, it will not because it is having additive join. Okay, so that is the introduction of spurious tuple. Again, I am saying with respect to the example, when I am combining R1 with R2, that is a kind of join. That is a kind of natural join. Okay, uh, that means the natural join query, if you write, it will like this. Select star from R1 to yeah. Select star from R1 R2. Yeah. Mm, then this is the query. If you write this, this will be a what? Where name equals to s name. Where s name is. Yeah. So by this, what will happen is that it will try to search for the common column, which is s name. Okay. Now s name will be combined. S name value will be searched with or matched with this s name value. So Smith matches with this value. If it matches, then the rows will be combined. That's why I combined Smith bolt initially with Smith project X. Then again, this Smith will match with this Smith. Smith bolt will be matched with Smith project Y. Okay. Then Smith knot will be matched with Smith project X. Smith knot will be matched with Smith project Y. Okay. But in the process, you saw that there is one row which is coming in, which is Smith knot, Smith project X. Smith knot project X. It is not present originally in the relation R or in the supply relation. So that is why this is called a spurious tuple or invalid tuple or wrong data. Okay. But if you divide the relation into R1, R2, R3 like this, and if you combine all the relations at a time, then you will not get this particular row, which also we proved, because when I am combining all these three together, first any two will be combined. Say R1, R2 is getting combined, then that means you have to combine this R3 with this resultant, because this is the resultant of R1 and R1 natural join with R2. So with this you combine R3, you will get Smith bolt. Bolt will be combined here. Project X, this is a valid relation. Then Smith bolt with project Y. Smith bolt project Y is also there. Smith bolt will be combined with bolt project Y. So Smith bolt project Y is also present, no problem. But Smith knot, this one Smith knot project X will be combined with will be obtained from nowhere, because knot is not present with project X. Knot is present with project Y and project Z. So this particular row you will not get in the R1, R2, R3 natural join.
Sir, the query in which we have written like select star from R1, R2. So there is no need to write any condition.
No, condition is required. This is automatically taken when you are writing natural join. It will automatically take the common column. If it would have been a equi-join, I would have written here where R1 name, R1 name equals to 2 dot. Okay, this is your equi-join which we saw in the last class. Remember?
Okay, sir. Thank you.
Because here S name is the common column and you are writing a equals to sign. But when it is same, when the column name is same, automatically it takes that it is a natural join. If it would have been, suppose the R1 is having S name as SF name, suppose SF name hota ho, that means the name is different, then natural join is not possible. Natural join has the mandatory thing that you have to have two columns of the same domain and same name. अगर वहाँ पे if the domain is same, the column name is not same, then you can apply equi-join. But if the column name and domain also same, then no need to mention, it will automatically take.
Okay, sir.
Okay. So this was your case of. Then how do you get to, how do you know that whether your division will be proper or not, whether this supply relation that you have divided into R1, R2, R3 will have the non-additive join property or not. Non-additive join means it should not generate any spurious tuple. So for that there is an algorithm. Okay, the algorithm is in the next chapter. Yep. This is the algorithm. This one, testing for non-additive join property. No need to remember the algorithm. It can be easily understandable from the example. Say I have I have one relation like this R having these many attributes. Okay, R1 is, that means I divided this R into two relations, R1 and R2. In R1 I kept E name, P location. In R2 I kept other attributes, that is SSN, P number, hours, P name, P location. Only E name is not here. Okay, so whether these two relations, when I combine, when I apply natural join to R1 and R2, will it give me back my R or not? That I have to test. If it is giving me back the R, then this is having non-additive join. That means the division is proper. If by combining R1 and R2 still you are not getting the R, then the division is not proper. So in order to test that, there is this algorithm which will help us. The given functional dependency set is this: SSN determines ename, P number determines P name, P location, SSN P number combined determines hours. Okay, based on this functional dependency and this division we will see. Okay, so create a table like this. Whatever is the number of attributes in the original relation, write them. Okay, no need to remember the algorithm. Directly you can get it done through the example. Okay, write all the attributes present in the table: SSN, ename, P number, P name, P location, hours. Fine. Then on the left hand side, how many division you made? R1, R2. So that many tuples will be there. That many row will be there. One is for R1, one is for R2. If it would have been R1, R2, R3, then another row would have been there. Fine. Now it is having only two division, R1 and R2, so two rows you make. Okay. Then yeah, what are the name of the columns present in this R1 relation? At that point you have to write the symbol A. It is the second column. E name is present in the R2 R1 relation and P location is present. So E name and P location. Under that you have to write A. This is second column, so A2. This is fifth column, so A5. Rest all will be having B symbol. B, B, here also B, here also B. This is first row, first column, so B11. First row, third column, so B13. First row, fourth column, B14. First row, sixth column, so B16. Similarly, in this R2, wherever these column names are there, I will have to insert A. So SSN will be having A. Since this is the first column, this is A1. P number is there. P number is having A. Third column, so A3. P name is there, so fourth column, so A4. P location is also there. Fifth column, so A5. Hours is also there, so sixth column, so A6. Only E name is not there, so it will having second row, second column, so B22. Got? This thing you can do. After that, after you mention this thing, use the functional dependency. Here my aim is to try and convert every B into A. After I write this table, after I mention this table, my aim is to convert the value present in each row, value B present in each row, convert it to A. Whether I can convert this into A or not, 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 that I have to see, and this one also. So how I can convert A to B, sorry, B to A? So the conversion will be done uh, based on this functional dependency. Here SSN is determining ename. Okay, so left side should be A. Here SSN is not an A, so you cannot convert it to A directly. It will be always converted based on any other A in the SSN. Here SSN is here, but it is below. It is a second row, and this side is already A, so you cannot directly convert this to A. Okay, or first row, once it is filled, no, there is hardly any chance to convert it to A. This one, suppose this is A1, this is B22. I could have converted this into A2 if this should have been a A1. We will get clear on this on the next example. I would have converted this into A1 or this into A2 if this would have been a A1, because this row will always refer its previous row. This is B22, I could have written here A2 if this would have been a A1, because it refers the left side. If SSN ename is here, SSN ename is here, no, the functional dependency, it is same for all the relation state, be it R1 or R2. So if SSN is determining ename here also it should have determined SSN ename, but here SSN is A. That means SSN is not at all present in this relation. So I cannot convert this into A. Similarly, these things also, P number, P name, hours, they cannot be converted into A. So neither this row I could convert all the B into A, nor this row I could convert any B to A. So this is stuck. That means I cannot do anything further. So this type of division is not preferred. Fine. See another example. Here R is having 1, 2, 3, 4, 5, 6 attributes: SSN, ename, P number, P name, P location, hours. R1 is having SSN ename, so I wrote SSN as A1, ename as A2, rest all will be B. Remember from the last example, whatever relations and whatever attribute it is having, under that attribute you have to mention A first. Then since nothing else is there, all of them will be having B. This is first row third column, so B13, first row fourth column, so B14, first row fifth column, B15, B16. Go to the next R2. R2 row is this. It is having P number, P name and P location. P number, P name, P locations. This will be A. Rest all will be B. Similarly, R3, SSN P number hours. SSN P number hours will be A. Rest all will be B. Okay. Now this is filled. Now I will try to convert all of the B into A. Whatever I can do, I will try. Okay. So how to try? Based on the given functional dependencies. So SSN ename is already there. These are A. No problem. P number, P name, P location. P number, P name, P location. None of them are A, so I cannot do anything. SSN P number hours. SSN is there, P number is not an A, hours is also not an A. So this cannot be converted. None of the B from this row can be converted to A. Now I check the second row, R2, B21, B22, A3, A4, A5. Here there is only one combination, that means A3, A4, A5. P number, P name, P locations. these are already A. Okay, so whatever attribute present in relation R2, they are already A. So nothing I can do with these three. Okay, now come to the third row. It has A1, A3, A6. Can I convert B3 to A? Can I convert this B into A? Yes, because it has A1 here. A1 is similar. Okay, SSN determines ename. So this A1 can be referred to this A2. From this A2, you can copy this value. That means this B32 can be written as A2 because it has the same left side. A1 with reference to the R1 column, R1 row, A1 is matching, so you can copy the A2 onto this. Fine. Now A3 is determining A4 and A5. Here A3 is there, so you can convert this into A4, this into A5. Okay, this got converted A4 and A5, and it was already A6, so you converted this to B into A, this B into A. So this row now contains all the A. There is no B in it. If at least one of the rows contains all the value as A, then this design is good. This R1, R2, R3, when combined back, they will give you this R. Fine. You see, this division, this R is same as this R. You divided this into R1, R2, two different relation. But when you combine these two different relations into as natural join, you will not get the original relation back. But the same relation when I am dividing into this three type of table having these columns, then you are getting your original relation back, because as per the algorithm you are getting all the value into A. So this R1, R2, R3 when combined, you will get non-additive join. That means the introduction of spurious tuple will not be there. There will be no additional tuples inserted when you do a natural join on R1, R2 and R3. Fine. This was your algorithm for testing whether your division are proper or not. It is having any additive join or not. Again, I am repeating, whenever a relation is given and you have to divide into possible set of relations, say R1, R2, R3, build a table with the column names same as the attribute name of the relation. For each division, each relation, build or insert a row, okay, based on the presence of the columns in the relation. Mark the value as A. If the column name is not present, mark it as B. Okay, A will be having A1, A2. This is first column, so A1 only. This is A2. Rest all will be marked with B based on the column and row number 1, 3, 1, 4, 1, 5. Similarly here you mark because these three A are only present. P number, P name, P location are present in the second relation. All will be rest, all will be B. Then in the third relation also, SSN P number hours are there. SSN P number hours. Okay, rest all will be B. Now what to do? I have to try and convert any row into all A. If any row got all A, then we have to stop. So in the first row, I cannot reduce anything to A because it has only two attribute, SSN and ename, and they are linked. SSN is determining ename, so this is fine. A1, A2 is kept, but you cannot reduce this B into A because there is nothing to be referred. These are always referred. Like here, I referred A1 and converted this to A2 by referring R1, because in R1 SSN was determining ename, so SSN can determine ename. So I converted this into A2. So here nothing can be done. Similarly in R2 nothing can be done because they are A3, A4, A5 are not at all present in the previous row. But in the last row, this got converted from the first row, this got converted from the second row. So all of them got converted into A. And your algorithm stops and you find that R1, R2, R3 are properly divided. That means the R is properly divided into R1, R2, R3. When you apply natural join on all these three, you will get your R back. Fine. So this was the non-additive join property. Now come to project join normal form. Project join or the fifth normal form says that a relation schema is in fifth normal form with respect to set of functional dependency, multiple dependency, and joint dependencies if for every non-trivial joint dependency in F plus every Ri is a super key of R. Okay, here also there is the mention of every non-trivial joint dependency. Again, the same thing, non-trivial means which is not obvious. Obvious, when it is said obvious, that means whenever out of X and Y is a subset of X. Okay, so in those cases that is trivial, that means that is obvious. But when it is non-trivial means Y is a separate thing. So R1 is a separate, R1 contains R1 on R2, there is no subset. That means R2 is not a subset of any other R, be it R1, R3, R5 or something, or R1 or suppose R4 is not a subset of R3, like that. None of them is subset of another. So in those kind of divisions, it will be in fifth normal form when every R is a super key of the original relation R. Okay, if you see the example, yeah. One second. Definition says every you see here a relation schema R is in fifth normal form when you are dividing the original relation into multiple R's, every R is a super key of R. That means you see these are all divided from this relation, and when you are combining these three, they are not having any additional spurious tuple introduced. Why? Because these are in 5NF. How do you know that this all are, they are all super key? That means all key relations, these are the super key. That means in this R, S name and part name is a super key. In this R, S name and project name is a super key. In this R, part name and project name is a super key. Okay, then you will say that, oh, yeah, why not in this? Because these three are also super key. This is also super key. S name, part name, project name. Why this is not in 5NF? I had to divide it into 3 so that these 3 are in 5NF. Now, any answer for this? I told you that a relation will be in 5NF if it is having all the attributes combinedly as the key. Here also all the attributes combinedly are the key. But this is not in 5NF because it says an additional thing. The additional thing is it should be having a non-additive join here. Every non-trivial joint dependency. Okay, that means this is having a joint dependency. Once you join them, you are getting non-additive join. Okay, every non-trivial joint dependency on this you have to perform. So this three, when you are combining, this is a non-additive join. Also, they are all super keys. So the columns present in the relations are all super key. This entire R, if you consider these two columns, these are super key. So that is why these three are in 5NF. But this is not in 5NF, because even if this combination is a super key, this is not having uh, the non-additive join property, because when you divide it into, suppose this 2, it will not be valid. You have to divide this into R1, R2, R3. Fine. Any doubt up to this? Today's class we saw join dependency, non-additive join, and how to find whether your division is having non-additive join or not. If the table any row of the table could be converted to A, then your division is proper. It is having non-additive join. Then what is 5NF? Project join normal form. Project join normal form. Okay, no doubt. Or you will go through once the topic. Go through. The ebook is there. There are hardly 2-3 pages. So read it and try to gather as much as possible. Okay, any doubt you tell me. Up to now your normalization class was there. Around how many classes? Around 7-8 classes we did for normalization. That was it. Normalization part, the most important part, is now you can say complete. Next we'll go to relational algebra, or we'll see in the next class. Okay then, no doubt then I can stop here.